Hello again, this is Chapter 7, Section 4. So Chapter 7, Section 4, we just finished up with percentage composition. Now we're moving on to empirical formula and molecular formula calculations. Make sure that you have a periodic table and a calculator while we go through this particular lesson. So periodic table, calculator. An empirical formula is the smallest whole number ratio of atoms in a compound. So for example, in C2H6, this is ethane. This is a compound whose subscripts can be reduced. And if you reduce those to lower whole numbers, you end up with CH3. The thing about empirical formula is empirical formulas, sometimes they are true compounds, oftentimes they are not true compounds, and we're going to go back and review Lewis structures real quick just so that you can see how CH3 is not a true compound in this example. So as I look at that, remembering our valence electrons, carbon, there's one of those. It's in group 14, so it has 4 valence electrons. 1 times 4 is 4. We have 3 hydrogen atoms. Hydrogen is in group 1, so there is 1 valence electron there. 3 times 1 is 3, so we have 7 valence electrons to find a home for. Automatically, you should realize with that odd number, something is probably amiss with what we're doing here. So you've got C, you have 3 H's, and we know that we can form a bond between all 3 of these. Forming that bond, that is 6 different electrons. Each bond is 2. We have 1 left over, and that 1 left over will go on carbon. If you count your electrons right around carbon, I see 2, 4, 6, 7. Hopefully you remember carbon needs 8 valence electrons. It does not have 8. It looks like it's in a radical form, which is not anything we are dealing with. So CH3 is not a true compound, but it is an empirical formula for what we are working on right now. So make sure you write down the next 4 steps that we go over. I'm going to add a little bit. It's the 4 steps defining an empirical formula. Step number 1, you have to find the mass of each element. Find the mass of each element. The mass could be given to you in the problem, or it could be given to you as a percentage. If it is given to you as a percent for each element, those percentages will add up to 100%. You can just drop the percent sign and use G for grams, and then you have your values that you need for step 1. So step 1, find the mass of each element. Step number 2, you're going to find the moles of each element. We are going to go back through some of our work that we did using our grids. So finding the moles of each element, just plan on, I'm going to have to set up a grid to find my answer there. Mass will be in the numerator. That's from step 1. So again, that is from step 1. And then if you are converting to moles, it's grams to moles here. So there's our conversion for molar mass. So the values that you put in, find in a different color. The values that you put in right here are going to come from the periodic table, because molar mass is that value off the periodic table based on 1 mole. Step number 3, you're going to divide the moles from step 2. So divide the moles that you get from step 2 by the smallest number answer in step 2 to find your new subscripts. You'll have to see this in action. I know it doesn't make a lot of sense right now, but we will divide each of our answers in step 2 by the smallest answer from step 2. This is where we get our new subscripts. Hopefully they're whole numbers. If not, we have a way to get around that. Step 4 is if in step 3 you did not get whole number subscripts, then you will have to multiply each of your subscripts by 2, 3, or 4 to get a whole number. For instance, let's say in step 3, you do your division and you come up with 1.33 as an answer. To get that to a whole number, you would multiply by 3 to get to 4. Anyways, we will work through an example where you have to multiply. Step 4 is not always necessary, but if it is, the most common multipliers you're going to use are 2, 3, or 4. So again, there's other options, but most of the ratios we'll deal with are a half, a third, or a fourth. Looking at this example, it's telling us to find the empirical formula for a sample of 25.9% nitrogen and 74.1% oxygen. If I go back to the first step of empirical formula, it says find the mass of each element, but in parentheses it says or percent. I told you that these percentages would add up to 100%, and they do. So we're going to start off with 25.9 grams of nitrogen and 74.1 grams of oxygen. And I'm going to open up a new screen for us to go work out these values. So we had 25.9 grams of nitrogen and 74.1 grams of oxygen. So that is step 1. Step 2 is find the moles of each element. We set up our grid. We're going to do a molar mass conversion. If grams is in the numerator, grams has to be repeated in the denominator. So there's our grams. Again, I'm going to highlight it for you as a refresher. Those have to match because we want our final answer in moles. And we're going from grams to moles. And we are dealing with oxygen at the bottom. We are dealing with nitrogen at the top. So with our grams, I told you that that is the mass of the element off the periodic table. I'm going to find nitrogen. We're going to 2 decimal places. Nitrogen is 14.01. And oxygen's mass off the periodic table is 16.00. And these are based off of 1 mole of each of those substances. And now it's a matter of multiplying our top values, dividing by what you see on the bottom. So in the first one, 25.9 divided by 14.01 gives you 1.85 moles of nitrogen. And in the bottom, 74.1 divided by 16 gives you 4.63 moles of oxygen. That is step 2, all of the work that is needed there. Step number 3 says divide both of those answers. We could have more than just 2 answers. It depends on how many elements you have. But in this case, we are dividing our answers by the smallest value. So the smallest answer we had coming out of step 2 is the 1.85. So we're going to divide both of these by 1.85 moles. Notice our moles cancels. And in the top, you're going to have a 1 for sure for at least one of your answers. So this is 1 nitrogen. So nitrogen's new subscript is 1. And when you divide the bottom one, you get 2.5 oxygen. So the new subscript for oxygen is 2.5. You know that we cannot have ratios or fractions for our subscripts. So in this case, step 4 is necessary. And step 4 says multiply all of your subscripts by a value to get the lowest whole number ratio you can. Since that is basically a half, we're multiplying times 2 in both cases. So I'm going to put the 2 right out front. So nitrogen's new value for subscript is a 2. Oxygen is a 5. Our final answer is N2O5. Make sure you look through this. Take some great notes. So that's the end of our empirical formula. Moving on to molecular formula calculations. A molecular formula is considered a true formula or true compound, and then the subscripts that you have for each of your elements represents the number of atoms in a compound that exists. So the CH3 that we had earlier we are going to be looking now to find out, okay, how do we get those subscripts to a place that represents a true compound? And so that question mark is what we're going to be doing. We're going to be finding that value. I have 4 steps plus 2 equations that you need to make sure you write down for the process of finding a molecular formula. You still have your calculator and your periodic table. Step number 1, you're going to find the empirical formula. Depending on the question that is given, the empirical formula may be given to you in the problem. Great, step 1 is real easy. Or they might tell you find the molecular formula, but they only give you the mass of each element, which would mean you would have to go through all 4 steps for empirical formula just to complete the first step for molecular formula. So really watch how your information is given. So step 1 is find the empirical formula. Step 2, you're going to find the empirical formula mass. This will involve setting up another grid to find empirical formula mass. Step 3, divide your molecular mass by the empirical mass. The molecular mass is always given to you in the problem. So the molecular mass will be given, and the empirical mass is what was calculated in step 2. So you're going to divide those two, and we have an equation. I'll go ahead and go to it to make sure you get this written down with step 3. So this is the equation that is being explained what's going on in step 3. You would write that down and then plug in your numbers accordingly. So molecular formula mass over empirical formula mass is equal to a value of N. N is that multiplier. N is what represents the question mark that was on the previous slide. And step 4, you're going to multiply each subscript, so the subscript for every element in your answer from step 3. So that is a makeshift equation that we have to go with step 4, and that's just saying your empirical formula that you got from step 1, plug it in here. Now you have your value of N from step 3. Multiply your subscripts times N. Let's go through an example. The empirical formula for ethylene is CH2. Find the molecular formula if the molecular mass is 28.1 grams per mole. Go ahead and get this question written down. I'm going to head on over to a new slide, and we're going to work through this process. When you're working out these problems in section 4, make sure you show all of your work. And again, we've got a couple minor equations going on. You'll show those too when the steps are needed. Step number 1, it says find the empirical formula, because our goal is to find the molecular formula, but step 1 is empirical formula. And this question was really nice. The empirical formula was given, CH2. Step number 2, we're supposed to find the empirical formula mass. The empirical formula mass. This is just the reverse of what we did earlier, just the reverse. We're going to go with the simplified version of what we did back in section 3 for percentage composition. I have 1 carbon atom. I have 2 hydrogen atoms. So looking at my periodic table, the mass of carbon is 12.01. And looking at my periodic table, the mass of a hydrogen, again to 2 decimal places, is 1.01. When you multiply those out, you get 12.01 grams, 2.02 grams, and we're going to add those values up for the total empirical formula mass of 14.03 grams. So again, that work that you see here is already a reduced version of a grid. Do not reduce it any further. Step number 3, we have that equation that we can look at. It was molecular formula mass over empirical formula mass equals a value of N. I told you molecular formula masses are always given, so look back at your question And the molecular formula mass was 28.1 grams per mole. You can just leave it as grams. And the empirical formula mass is what we just calculated in step 2, 14.03 grams. And when you get your value of N, if your math does not lead to something really close to a whole number in step 3, for the questions you're going to be given, you've done something wrong. And this is very close to the number 2 as our answer, so that is our value of N, is 2. And then step 4, I gave you this. I'll call it an equation. It's a good starter base. EF is empirical formula, so we are plugging in our empirical formula from step 1, which was given. Very nice of them. And our value of N is 2. You're going to multiply each subscript by that. So your final answer is C2H4. But again, that is the answer for ethylene. Looking at this right here, make sure you show all of the work that I have shown. Do not skip any parts. Don't assume I know where your values are coming from.